Welcome to This Explainer. Today we're diving into something completely wild, an explosive, unexpected event that literally reshaped a piece of the moon. We usually think of the moon as, this quiet, static place, a dusty museum of ancient crater impacts from billions of years ago. But today, we're looking at exactly what happens when modern, discarded space hardware violently introduces itself to the lunar surface. It's not just a story about space junk. It's a massive tale of chaotic orbits, high-speed kinetic impacts, and, believe it or not, a huge, unexpected silver lining for science. Let's get into it.
Okay, let's dive right into this. What actually happens when a 4-ton rocket hits the moon at 5,400 miles per hour? Just let that visual sink in for a second. We aren't talking about one of those gentle, carefully engineered lunar landings where the thrusters do this delicate little automated ballet to touch down safely. No way. We're talking about a massive, unguided chunk of metal hurtling completely unchecked through the dead vacuum of space, aiming straight for the lunar dirt. It's the ultimate cosmic collision, just raw, unfiltered kinetic energy. And that's exactly the scenario we're breaking down today.
Section 1. Unexpected lunar crash.
All right, picture this. It's August 5th, 2026. Out near the moon's Einstein Crater, something unfolds that literally sounds like a sci-fi movie. An old piece of an Elon Musk rocket just smashed into the moon, and NASA was completely powerless to stop it. To be clear, this wasn't a fully operational rocket. It was a discarded 4-ton upper stage from a SpaceX Falcon 9. Basically, imagine a giant, empty metal cylinder about the size of a school bus. So why couldn't ground control do anything? Well, that comes down to the ruthless reality of orbital mechanics. Once this thing was locked into its fatal trajectory, there was zero anyone could do. No active thrusters, absolutely no fuel left to ignite, and all the communication links were long dead. The teams back on Earth just had to sit back, watch the math, and wait as this massive cylinder inevitably fell toward the cratered surface.
Section 2. The SpaceX launch backstory.
Now, what's really interesting here is how a completely successful mission somehow spiraled into this chaotic orbital drift. If we rewind a bit, this whole saga actually started back in January of 2025. SpaceX launched a Falcon 9 rocket with a legitimate and highly successful purpose. But by early 2025, after flawlessly doing its job way up above the Earth, this upper stage simply ran out of fuel. Usually, with low Earth orbit missions, they deliberately steer these stages back into the atmosphere so they burn up safely. But because this specific mission went so high up, the rocket couldn't make it back. It was totally stranded in high orbit, no juice left to course correct. And that set the stage for our grand finale on August 5th, 2026, when this 4-ton ghost ship met its explosive end near the Einstein Crater.
And just to be perfectly clear about that initial 2025 launch, SpaceX wasn't just blasting junk into the void for fun. The Falcon 9 absolutely nailed its payload delivery, dropping off 2 incredibly sophisticated private lunar landers, Firefly's Blue Ghost and iSpace's Resilience. The mission itself, a total commercial triumph, a real engineering marvel. The rocket did exactly what it was supposed to do. The problem only kicked in after the fact. It's actually kind of ironic, right? You have this multi-million-dollar delivery vehicle packed with cutting-edge computers, and the second the fuel tanks run dry, it instantly turns into a dead, uncontrollable ghost ship just drifting in the cosmic ocean.
Section 3. 18 months adrift. So for over a year and a half, this massive metal tube was completely at the mercy of deep space physics, just tumbling in this chaotic, invisible dance. Let's look at the 2 main culprits that essentially steered it to its doom. On one hand, we've got solar radiation. Now, I know it sounds crazy, but light from the sun actually exerts a physical pressure. Over 18 months, trillions of photons constantly slammed into the large reflective side of this empty rocket. It acted kind of like a super inefficient solar sail, just gently nudging the rocket day after day. And on the other hand, you have gravitational forces. The rocket got caught in this wild, unpredictable tug-of-war between the Earth's massive gravity, the sweeping pull of the moon, and the distant pull of the sun. So between the subtle push of sunlight and the complex gravitational pull of 3 different bodies, the math just became totally chaotic, ultimately throwing it right onto a collision course with the moon.
It's honestly fascinating how a drift so incredibly slow can end in something so violently abrupt. I mean, this was a slow, agonizing 18 months drift. But remember, space is a vacuum. There's no air friction, no drag to slow you down. So when the moon's gravity finally locked onto the rocket in its final hours, it just started accelerating. That peaceful, floating image we all have of space junk, completely gone. It transformed into a massive, uncontrolled dive bomb going 5,400 miles per hour, pulling insane G-forces as it plummeted directly toward the silent lunar surface.
Section 4, Anatomy of the Collision.
5,400. That is the staggering speed at the exact moment of impact in miles per hour. For a metric, folks, that's a blistering 8,690 kilometers per hour. To put that into perspective for you, that is roughly 7 times the speed of sound here on Earth. Now, at that extreme velocity, the physics of solid metal start behaving very, very differently. It doesn't just bump into the ground or crumple up like a fender bender. No way. At 5,400 miles per hour, the structural integrity of aerospace-grade aluminum basically means nothing. It instantaneously vaporizes and shatters the second it touches down, sending an absolutely immense shockwave straight through the lunar bedrock. And this brilliantly illustrates the sheer kinetic power of the crash. The number 3 here, that represents 3 tons of TNT. And here is the absolute wildest part of this whole event. The rocket was completely empty. There were no onboard explosives, no volatile chemicals, literally 0 combustible rocket fuel left. The explosion on the moon was generated entirely by kinetic energy. It was just the pure mass of a 4-ton rocket multiplied by an insane velocity. It's a pretty stark reminder of the raw power of momentum. Just dead weight slamming into rock unleashed the explosive energy equivalent to detonating 3 tons of TNT.
So what exactly happens to the moon when 3 tons of TNT worth of kinetic energy goes off in a fraction of a second? Well, it leaves a very permanent, highly visible scar. The sheer overwhelming force of the impact carved out a brand new crater, estimated to be anywhere from 20 to 30 meters wide, right out there near the Einstein Crater. Literally, in the blink of an eye, humanity forcefully rearranged the lunar topography. This wasn't some random micrometeorite. This was a man-made structure creating a massive geographical feature that, frankly, will probably sit there pristine and untouched for millions of years.
But the crater wasn't even the most dramatic result. The violent impact blasted a colossal lunar dust plume straight up. How far up? Try 100 kilometers. Just let that sink in. The shockwave was so incredibly intense that a massive cloud of subsurface soil, regolith, and vaporized rocket debris shot 75 to 100 kilometers out into the black vacuum of space. It created this towering, temporary monument of dust way above the lunar horizon. And as you'll see, it's actually that staggering dust plume that leads us to the most exciting and unexpected part of this explainer.
Section 5, The Scientific Silver Lining.
So immediately after the impact, European observatories pointed their most powerful instruments straight at that towering 100-kilometer dust plume. Because the blast literally excavated ancient soil from deep beneath the surface, stuff that hasn't seen sunlight in eons, they were able to detect the rare chemical fingerprints of sodium and lithium. This was a massive, massive win for astronomers, because finding those elements really helps us decode the moon's primordial makeup and its fiery history. Meanwhile, over at NASA, their first priority was, of course, public safety. They rapidly analyzed the trajectory data and quickly confirmed there was absolutely 0 danger to Earth. But even better, they confirmed the crash site posed no threat whatsoever to any of the highly planned locations for future lunar bases.
So the really crucial point here is how this total accident is directly helping NASA prepare for the Artemis missions. Artemis isn't just about going back and planting another flag. The goal is a permanent human presence on the moon. And NASA is actively using the data from this unplanned crash to study real-world impact physics. They are literally watching how lunar craters form in real time, analyzing the ejecta patterns and how energy distributes in a vacuum. Plus, and this might be the biggest takeaway, this event is forcing us to radically advance our space debris tracking. If we're actually going to have astronauts living and working in lunar habitats, keeping precise tabs on 4-ton, 5,400-mile-per-hour debris isn't just a fun academic exercise anymore. It's literally the difference between life and death for those future explorers.
NASA actually views this event as, quote, a rare, valuable opportunity to study impact physics. I love this because it perfectly captures the adaptable mindset of the scientific community. Humanity accidentally drops a massive piece of space junk on the moon, and rather than just writing it off as orbital litter or some sort of bureaucratic failure, scientists immediately pivot and turn it into a prime experiment. Essentially, this accident handed the scientific community a free, massive-scale kinetic impact test that we probably never could have easily funded or orchestrated on our own. Talk about making lemonade out of orbital lemons, right? But this does leave us with a pretty vital, provocative question to consider.
What does this explosive event mean for the future of space junk as humanity establishes its first lunar bases? Look, we got incredibly lucky this time around. The rocket stage had an empty patch of dirt, nobody was hurt, and we were handed great scientific data on a silver platter. But as the orbit around the moon gets more and more crowded with commercial missions, private landers, satellite constellations, and eventually human habitats, uncontrolled 4-ton projectiles become a massive, unacceptable liability. It's a high-stakes puzzle that international space agencies absolutely must solve in the coming decades to make sure our expansion into the cosmos is safe. Thank you so much for joining me for this explainer. Keep your eyes on the stars and stay curious.